So now let's look at the volume of another. These are called prisms. Okay, and we'll talk about why it's called a prism. So we just did cylinder, now we're doing a volume of a hexagonal prism. This is called hexagonal. You name the prism after the base. Whatever the base is determines the name of the prism.
Miss Hannah, is there only a hexagonal prism or there's
Everything.
okay.
Triangular prism. You can make the base a trapezoid, trapezoidal prism.
Oh.
Okay? The base can be all kinds of different shapes. What makes it a prism is that the faces that are not bases are rectangles. So if you look here, the base is a hexagon, right? And the top is also a hexagon. But what do you notice about the lateral? Lateral means sides, the lateral faces. So the non-bases. What shape is that?
A rectangle.
Yep,
Okay.
that's what makes it a prism. All the non-base sides are rectangles.
Oh, okay.
And the base doesn't have to be on the bottom. Like we can draw the prism sideways. The way you recognize the base, it's the faces of the 3D figure that are not rectangles. Now, if everything's a rectangle, then it's a rectangular prism, right? But so prisms have rectangular lateral faces, and it has prisms have two bases, and they could be different shapes.
Mm-hmm.
So now, if we want to find the volume, the only thing the formula sheet's going to give us is that capital BH. So we can't do anything with that until we figure out what capital B is. So the height, let's say, is 12 meters. Okay, that's good. That's our H, but we're still missing capital B. Now, the shape at the base is a hexagon. They could give you different dimensions of the hexagon, but I'm going to start with the apothem. The apothem is the distance from the center of the polygon, which is a hexagon in this case, to a side. So I'm going to redraw the base separately so we can look at it. So this right here is called apothem. The apothem is the distance from the center to a side. Hexagons or polygons also have radius. The distance from the center to a corner, that's the radius of the hexagon. But you don't always need it. Right now we're going to work with the apothem first. Okay, so the formula sheet does have a formula for area of a regular polygon. And what does that mean? Let's dive in. Okay, regular means all sides congruent, all sides and all angles congruent. And a polygon is a closed figure with three or more sides. So what you're used to, triangles, quadrilaterals, pentagons, hexagons, etc. The formula is A equals 1/2 apothem times perimeter. The A is apothem and the P is perimeter.
So this is for all prisms?
No, we're not working with the prism right now. We're working with just the base. This is
Oh,
a
okay.
2D hexagon. This formula is for all polygons,
Oh, okay.
pentagons, hexagons, octagons, anything that has more than four sides. Because if you have a rectangle or a square, you could just do length times width. It's when you have triangle, you do 1/2 base times height. for area. But once you get into more than 4 sides, you want to use this formula. Any questions on that?
No.
Okay, so to use that formula, you need to know what the apothem is, and you need to know what the perimeter is. So let's say I told you the apothem is 5 meters, and let's say I tell you one side of the hexagon is 7 meters. So we need to use the formula area equals 1/2. The apothem is 5, but the perimeter, well, one of the sides, it's regular. It's a regular hexagon. So that means all the sides are the same. So all the sides are 7, right? Even if my drawing doesn't look like that, I didn't use any rulers or anything like that. So I'm going to put tick marks to show all the sides of the hexagon are the same. So there's 6 sides and they're all equal to 7. So we're going to do 6 times 7. 42 meters is the perimeter.
Oh, okay.
So now we have A equals, you could just put that in your calculator, right? But I'm going to use some mental math. 1/2 of 42, I like to do that one first because it's an even number. Half of 42 is 21 meters times 5 meters. 105 meters is the area squared because we're multiplying. Area is always to the second power. The units are. So the area is 105 square meters. That's your capital B. So now we go back to our volume formula and we write V equals 105 square meters times 12 meters. And then you put that in your calculator. 105 times 12. And we get 1,260 cubic meters as our volume. All right, so finding the area of this hexagonal base, because we had the apothem, all we had to do is use the formula. However, sometimes they don't give you the apothem. So here's where it's going to be a little more complicated. So let's go back up to that hexagon. Because in the geometry test, especially if you want to get a level 4 or 5, you have to be prepared to apply multiple concepts to the same question. So let's say you have the hexagon, you know that, let's say the side is 8 centimeters, but you don't know the apothem, so the apothem is missing, but you know that you can form a right triangle here, okay? So we're going to use that to our advantage. So here's where it's going to get interesting. I give you no other information. You're like, what the heck? 1/2 apothem times perimeter? I can figure out the perimeter. 8 times 6. The perimeter is 48. But the apothem is missing. What do I do? Well, let's see. Inside the hexagon, you can draw a bunch of triangles. Okay? Even though my triangles don't look like they're the same, it's because my horrible drawing. But all of the sides are 8 centimeters. So if I focus on the little triangle that I formed here, this forms a right triangle. And now this is 4 because it's split in 2. Okay, and then it's a regular hexagon. So not only are all the sides the same, all the angles are the same. So I'm going to see how many angles I have in this little rotation of 360. When you go in a full circle rotation, that's 360 degrees. But there's 1, 2, 3, 4. Did I count right? 5, 6. Yeah, there should be 6. So we're going to divide by 6. We get 60 degrees. So that means this little area right here, this little corner is 60 degrees. But I just split it in half when I made a right triangle. So how many degrees is this piece right here?
30.
Exactly. So I'm going to redraw that triangle that's inside the hexagon. and put 30 here and 4 here. Do you know how we got those numbers? Is that
Yes.
clear? Awesome. So now this is a 30, 60, 90 triangle because triangle angles have to add up to what?
180.
Exactly. So if this one's 90 and this one's 30, that's already 120. So that other angle has to be 60. And 30, 60, 90 triangles have special properties. Do you remember what they are?
Uh, yeah.
Okay. The side across the 30 is x. What is the side
Yeah.
across 60?
I'm trying to remember my brain. Isn't it the square?
It has a square,
Square,
but what
yeah.
number's inside?
2?
No, 3.
It was 3? Oh,
40,
okay.
yeah. The 45, 45, 90 has square root of 2. And
Uh,
then what is the side across 90?
the hypotenuse. 2A.
Good. So now the side across 30 is 4. So that means this the long leg is 4 square root of 3. And this one is 8. But we don't need this one. We need the apothem. Which side is the apothem?
4, 4 square.
Square root of 3. Yep. So we got our apothem. So we had to do special right triangles to find our apothem. Sometimes you even have to do trigonometry to find your apothem. Now that we have our apothem, we can go. Okay, it should be better now. Pardon there, it froze for a moment. Do you hear me?
Mm-hmm.
Okay, so now that we have our apothem, we can go back to the original apothem area formula. Area equals 1/2 apothem, which was 4 square root of 3 times 48. Area, half of 4 square root of 3 is 2 square root of 3 times 48. So we're going to do 48 times 2. We get 96 square root of 3. So that's our area of the hexagon. That's your capital B. Now, if this is the base of a prism, we would go back to the prism. So let's say we had our hexagonal prism. And let's say the height was 20 centimeters. We would do V equals capital BH. V equals 96 square root of 3 times 20. So 96 times 20. 1,920 square root of 3 centimeters to the third power. I left it in terms of square root of 3, but you could also just multiply the square root of 3 out and then you would have to round. Be careful when you round, though, actually, because you need to pay close attention to what they tell you. If they tell you to round to the nearest tenth, hundredth, sometimes they'll tell you round to the nearest cubic centimeter. Students are like, what the heck is that? That just means nearest whole number. So let's try that. 1920 times square root of 3 is, we get, if we turn this into a decimal, 3,325.537. So let's practice rounding it. What would this be to the nearest tenth?
5. Oh, wait, no. Yeah,
Yeah,
3,000. Oh, 5. Okay.
you're right. That's a tenth. 3,325.5 cubic centimeters. What about to the nearest hundredth?
Uh, that would be. Mm, it wouldn't. Would it say the same?
This is the tenth place. This is the hundredths place. You look next door. 5 or more go up one
Um,
more. 4 or less stay and rest.
okay.
So what
So
happens to the 3?
it goes up.
Mm-hmm. Cubic centimeters. But if they tell you to round to the nearest cubic centimeter, that just means whole number. So what would this be to the nearest cubic centimeter?
3,300 and no, it's not 30 because
No, that's tens place. Nearest whole number would be this one, the ones.
oh, got around of 6.
Yep, because of the 5 next door. you Vixen. So
Okay.
you definitely want to know how to round it because you don't want to get it wrong after doing all the work because of rounding. Now, this may have seemed very complicated, right? Because you're like, what the heck with that capital B? You have to do special right triangles. Sometimes you have to do trigonometry. So take your time with these. Take time to find out what your capital B is. Don't just be in a rush to use the formulas on the formula sheet.